In part 2 of the module, Hands-on Machine Learning, we will try different machine learning models. For that, we need to download the software called Orange Data Mining. So we go to a web browser and to this address, orangedatamining.com, to download the software, which is free and available both for Windows and Apple machines. So we can open any web browser and search for Orange Data Mining. And you can see that the first search results is Orange Data Mining. We click on the hyperlink and it takes us to the download page. We click on Download Orange. Here it gives you two options. One option is for Windows, the other is for Mac OS. And each of them has a sub-option. For example, for Windows, you can download and install it or download and run it using portable version. For Mac OS, because the new Mac computers, they use their own, Apple uses their own CPUs architecture. It's new architecture, ARM64. You can use the first one, Orange for Apple Silicon. If you're using an older version of Apple computer, you can use the Orange for Intel. So before downloading the Mac OS, make sure that you know what your CPU is and then download them. Because I'm using a Windows machine, so I download Orange for Windows. And you can see that the file has downloaded. So the next step is to locate the file, to download the file and install the software. Once the Orange Data Mining software is downloaded on your machine, you can double click on the file to open it. You can see that the icon is a smiling orange with thick black glasses. So double click on that and open the Orange Data Mining software. The first screen is a welcome screen. It says welcome to Orange. You can see some icons. In Orange, they call them widgets. So if you want to produce a new project, you click on new. If you have already created a project, you want to open it, you click on open. And if you know how many projects you have already done, you can find the most recent ones here. If you're new to data mining using Orange software, there are some tutorials on YouTube. There are also some documents to get you started, some help files, some examples, and some mostly technical documentation. We can close the Welcome to Orange splash screen. And here we can see that the software GUI has two main parts. The largest part is called the canvas, like a drawing canvas, but instead of drawing, you put some machine learning models, different components, and then connect them together. And those components are found on the left pane. Here we can see that there are different widgets for different functions. These widgets are arranged in a way that they somewhat follow the workflow in a machine learning. And if you remember the workflow in a machine learning, we always start with some question and some data. So to get the data, we can have data in a file already on a computer or a URL, or you can import a CSV file, or you can use data built into the software, Orange software. In the second group of widgets, you have some tools to transform the data, such as, for example, you are interested in only in some columns or some rows, or you want to merge two data sets. So you can use some of the widgets here in the transform. After the transform, you can visualize your data set using different plots like scatter plot or line plots or bar plots. The most important part is the model part. Here you can see that there are different supervised machine learning models, such as, for example, random forest, gradient boosting, linear regression, logistic regression. After modeling your data, you want to see how well they perform, so you need to use some evaluation tools, such as, for example, test and scoring or ROC analysis or confusion metrics. We also learned that machine learning can be categorized into unsupervised models. So here we can use unsupervised models for machine learning, which use unlabeled data so that the machine can find some patterns such as clusters or group or relationship or some latent dimensions. If you're interested in image analytics or bioinformatics like genetics or some educational software or applications, or for example, if you want to teach something, or if you're interested in modeling text data, for example, predicting text or doing sentiment analysis, you can use different widgets for those functions. Now let's just start doing some machine learning. So the first machine learning methods we are going to demonstrate is the linear regression, and we want to predict body fat. So as we follow the machine learning workflow, we need some data. To get the data, we use some built-in data sets from Kaggle, which is built into the software. So if we drag dataset widget, and if we double click on that, we search for body fat. And here we can see that body fat, it is shown in the search results. We can see that there are 252 patients called instances, 16 variables, and the target is numeric, it's number, and the domain of the data is in health sciences. Below you can see a description of the data. To download the data in your machine, you double click on the name of the dataset, body fat prediction. So after double clicking, this circle should be green. If it is not green, it means that it is not on your computer. So you should double click and maybe wait a bit so that it is downloaded onto your computer. Now I close this. A good practice is to rename the widgets. For example, here, because my dataset is body fat, I want to rename the dataset into body fat. So I right click on it and rename and call it body fat data. Next, I want to look at the data and look at what variables are in the dataset. So if you drag this part, a list will appear and you can choose data table. This is one method. Another method is to click on data table here and drag it here. But this is empty because you need to connect the body fat data to data table viewer. Now if you double click on that, you can see that the data is populated, and you can see the variable body fat, patient ID, the age, weight, height, and other measurements. So these are the features or predictors, and we want to use those features or predictors to predict body fat. If you notice, this ID column has a different color. It shows that this column is not used in data analysis. It's called metadata. On the left, you can see some information about the data set. There are 252 instances and no missing data. There are 14 features or predictors. The outcome is numeric. And there's one meta attribute, which is the patient ID, which means that it's not going to be used in machine learning analysis. Now I close this window. If you go to transform, select column, if you connect them to data table and double click on that, you can see the features, which variables are features, and which variable is the target or outcome. And here we can see the name of the column which is not used in the computation, which is the patient ID. And it's called the meta. So it's a meta variable. A meta variable means it is not used in data analysis. Now I close this window. Now we are ready to do some machine learning because we do have the data and we know the target variable, we know the features. Because the target variable is continuous and numeric, we can use the linear regression. So after transform, you can see the model and we search for the linear regression, and here we can drag it to the canvas. Just put it here. And then we connect the selected column to linear regression. So this stage of machine learning is called fitting or training the model. So the model is now trained. If we double click on that, we can see what parameters of the model are used. So here are some technical parameters. We are not concerned with that in this module. For advanced users, those who are more advanced, they can play with these different parameters. Now this model is fit or trained. Now we want to know how well the model has been trained and how well it can predict new data. To see how well the model performs, we need to evaluate the model. So let me close this model and evaluate. For linear regression or other machine learning methods, we can use the test and score. So we click on it and drag it to, let's say here, and then it will ask us, what machine learning are you going to test? So we say that we have a linear regression. So we connect it here. It also needs more additional data to test the trained model on the new data. So we add some data to the test model.